Have you ever wondered why our mid-latitude regions experience such varied weather, shifting between warm spells and cooler fronts, or why temperate zones aren't just consistently mild all year long? It is all part of a fascinating global balancing act. The Ferrel Cell plays a crucial role in global heat transfer by acting as an indirect atmospheric circulation cell that helps redistribute heat from the equator towards the poles and cold air from the poles towards the equator. This cell operates between approximately 30 and 60 degrees latitude in both the northern and southern hemispheres, essentially creating a dynamic conveyor belt that exchanges thermal energy across temperate zones. This indirect circulation is driven primarily by the Hadley and Polar Cells, which are its neighbors. Air descends at around 30 degrees latitude, a region known as the horse latitudes, having cooled and dried after rising at the equator within the Hadley cell. This descending air then flows poleward along the surface, warms as it moves, and eventually meets colder air masses coming from the polar regions at the polar front, typically around 60 degrees latitude. Here, the warmer, lighter air is forced to rise over the denser, colder air, completing the cell's loop as it returns equatorward at higher altitudes. This entire process effectively exchanges heat between the tropics and the polar regions. Understanding the Ferrel Cell means recognizing its influence on day-to-day weather patterns in temperate zones. You can observe its effects by noticing the frequent passage of weather systems like cyclonic storms and anticyclones that characterize these latitudes. These systems are often born out of the clash between the warm, moist air moving poleward in the Ferrel Cell's surface flow and the cold, dry air from the polar cell, creating the dynamic weather fronts we experience. A key concept here is the polar front jet stream, a powerful river of fast-moving air located high in the atmosphere, often at the upper boundary of the Ferrel Cell. This jet stream meanders significantly, creating troughs and ridges that profoundly influence where and when weather systems develop and move. Its shifts can lead to prolonged periods of unusual warmth or cold, illustrating the intricate link between atmospheric cells and regional climate variability. Ultimately, the Ferrel Cell ensures that heat is not simply trapped at the equator nor cold perpetually concentrated at the poles. By facilitating the exchange of energy between different thermal zones, it helps maintain a more moderate global climate than would otherwise exist, making our planet habitable across a wider range of latitudes. This constant atmospheric dance is a testament to Earth's complex and self-regulating climate system.